Okay, guys, here is 49A. If you look over in the book, it tells us that 1 gram of each reactant, and it also mentions that it wants you to figure out the mass of each product. So notice I went ahead and I put 1 gram for each one, and then I put circles for each one there. Okay. I've also went ahead, excuse me, reach here, I have to grab my calculator. I also went ahead down here and recorded the molar mass of each of the different things. So now, what I would do here is, again, we have to go to moles first. So I would take the 1 and I would divide by 270.03, which is the molar mass of UO2. Uranium is just so heavy. And it ends up being 0.00370. Again, 3 sig figs I'm trying to keep here. Over here, I'm going to take 1 and I'm going to divide by 20.01. And that is a small, but not nearly as small, 0.04. 9. Let's see, actually I have to round it, don't I? So it'll be actually 0.0500. There we go. Is what that would be. Okay, now it looks like, so I think I double check I did balance it already, yep. Okay, so the question is, what is it going to run out of first? And again, anytime you have more than 1 gram you're starting with, you're going to need to use a limiting reactant, see which one they're going to run out of first. And remember, what you do is you just take the number, that's the mole number, not the grams number, the mole number, and you divide the mole number by the coefficient above it. And that is this number here, and be 0.00370. That's really easy. This one over here needs to be divided by 4. So it'll be 0.05 divided by 4. And that gives me 0.0125. This one is definitely the smaller number here because there's 2 zeros, while this only has 1. Okay, so this is the smaller number. So that means this is the number we're going to be using going forward right here. Okay. So now actually to make it pretty easy, okay? So I'm going to go ahead and divide this number by the one above it, which is 1, and then multiply it times 1. So divided by 1 times 1 is shockingly the same number, 0.00370, okay? And then over here, I do the same thing. Let me go ahead and type in my calculator, 0.0037. And then divide by 1, no big deal, but I need to multiply it by 2 because there's a 2 coefficient over here, and I end up with 0.0074, okay? Now, to go downward, you need to multiply by the molar mass, okay? So, since I have this one already typed in my calculator, I'm just going to do this one first. So, I'll go this one times the 18. So, this one times 18.02. And that is going to end up with a grams of 0.133 grams, okay? And then over here, you could also, on this one here, do the 0.00, this number here, times that number when going down, so 0.0037 times 314.02, really big number. And we end up with 1.16, it looks like, 1.16 grams. Okay, let's go double check if that's the same number in the book. It's number 49A. And they got 0.1, yep, 116. Yep, and so they got the same answers we did. So hopefully that helps, and hopefully my video taking did not make you too dizzy. Anyway, I'm going to go ahead and record 49D next. Thank you.